Hello friends, welcome to my YouTube channel RJK Tutorials. So today I'm going to take a presentation on a topic called as correlation. Now correlation and regression are the two important topics that are studied in statistics. So both correlation and regression are depending on each other. Now correlation is a topic where we study the degree of relationship between two or more variables. Now, this concept of correlation was first introduced by a person called Francis Galton. He tried to measure the degree of relationship between two variables. Now, what do you mean by degree of relationship? Now, if you take two variables, how the values in the variables are moving, whether they are moving in the same direction or in the opposite direction. So, this degree of variation is actually called as the degree of relationship. So correlation is actually used as a tool to measure this degree of variation in the variables. Now let us look at the definition of correlation. So what is the meaning of correlation? So correlation is a statistical measure that indicates the extent to which two or more variables fluctuate together, and based on that you have what is called positive correlation or negative correlation. If the values in both the variables are moving in the same direction, then we call it as a positive correlation. That is, if both are increasing or decreasing, we call it as a positive correlation. But in case of negative correlation, so one is increasing, other is decreasing. Say for example, x is increasing, the y is decreasing, or x is decreasing and y is increasing. If the values are moving in opposite direction, then we're going to call it as a negative correlation. So different statisticians are given different meanings for this correlation. So these are some of the definitions given by the statistician. According to E. Davenport, the whole subject of correlation refers to interrelation or interrelationship between separate character by which they tend in some direction at least to move together. So he's trying to explain the interrelationship between the two variables. That interrelationship is based upon how the values are moving in a particular direction. So based on that you have some sort of a relationship. So that relationship is actually called as correlation. Now let us know about the important uses of correlation. So basically there are three important uses of correlation. So it is used to test the hypothesis about the cause and effect relationship. That means we're trying to find out what is the effect of one particular thing on the other one. Now, for example, giving people with the different amounts of a particular pharmaceutical drug and measuring their blood pressure. So a particular drug can influence or fluctuate the blood pressure. So that is what you're trying to measure. So this is what is called as the cause and effect relationship. And the main use of correlation and regression is to see whether two variables are associated without necessarily inferring a cause and effect relationship. That means we are trying to find out, is there any association between two or more variables. Now, if an association is found, the inference is that the variation in X may cause the variation in Y. For example, you have income and expenditure. Suppose if you take X as an income and Y as expenditure. So if there is a fluctuation in the income, definitely the amount of money spent as an expenditure also gets fluctuated. So if you get more income, definitely you'll try to spend more. So if your income decreases, definitely your expenditure also decreases. So this is what is basically the meaning of the second, the use of correlation and regression. The third common use of linear regression is estimating the value of one variable corresponding to the value of other variable. So this is pertaining to the regression. So this I'm going to explain in the chapter of regression. So what are the advantages of correlation? So correlation is going to help the researchers to collect more data related to the various experiments conducted. So a particular experiment is going to give a outcome. So that thing is measured in the correlation. Correlation also helps to conduct the research further to obtain more data about a particular a problem or a situation. And it is a quantitative measure. So data gathered in correlation analysis can be analyzed, can be used for other type of analysis. So that is the meaning of that. So the main disadvantages of correlation is, now in correlation we're going to deal only with the quantitative data, so quality data cannot be used. And the other thing is like correlation, researchers only uncover a relationship, it cannot provide a conclusive reason for why there is a relationship. So that means it's going to tell you there is a relationship between X and Y, but why this X and Y relationship is being created or existing, so it's very difficult to tell actually. A correlation finding doesn't reveal which variable influences the other. For example, finding that wealth correlates highly with the education doesn't explain whether having wealth leads to more education or more education leads to more wealth. So in this way, you cannot exactly tell whether to what extent a particular variable is going to create an influence on the other variable. So reasons for either can be assumed, but until more research is done, causation cannot be determined. So what is the main cause of this relationship? It is very difficult to know for it. And the other one is like here a third unknown variable may be causing the relationship. For example, living in a city of Bangalore can lead to both wealth and education. Now here Bangalore is one more variable actually. So wealth is one variable and education is one more variable. Now since you're living in Bangalore, you're getting all the amenities of life, you're getting all the infrastructures, so therefore, your standard of living may increase. You may get a better education. Because of better education, you may get a better job opportunities because there are more companies in Bangalore. So here, the influence of the unknown variable, the third variable, cannot be measured. So that is the disadvantages of correlation. So talking about correlation types. So broadly, correlation is classified into three types. On basis of direction, it can be called as positive, negative, or a partial correlation. Based upon number of variables, you have one like you have only two variable correlation called simple correlation. Then you have a multiple correlation. That means if you are analyzing a relation between more than two variables, like three variables, four variables, five variables, then we're going to call it as multiple correlation. On the basis of change, whether the change is happening in similar direction or in opposite direction or in different direction, it can be classified as linear. So in linear basically tells the values are moving in the same direction, in the same way. So if you're going to plot these values, you're going to get a straight line. So therefore they're called as linear correlation. So based upon the direction, the correlation can be positive or negative or partial correlation. Based upon the number of variables, it can be simple correlation or multiple correlation. Based upon the basis of change of values in the variable, you can call it as a linear correlation or curvilinear or non-linear correlation. Now, what do you mean by positive correlation? As I said earlier, correlation is said to be positive correlation if the values of two variables are moving in the same direction. Production, expenses, and sales. Okay, then height and weight, water consumption and temperature, study time and the grades. So these are both related in the same direction, so they're called as positive correlation. Now talking about negative correlation, as I told earlier, one increasing, other decreasing. So price and quantity demanded, if the price decreases, quantity demanded increases. If the price increases, quantity demanded decreases. Then similarly, alcohol consumption and driving ability, if more alcohol is consumed, your driving ability decreases. So this is what is called as the negative correlation. I think you can understand these examples here. If X is increasing, Y is also increasing, vice versa. They are called it as positive correlation. If X is increasing, Y is decreasing, or vice versa, it is called as the negative correlation. Example, as a TV time increases, grade decreases. That means if you spend more time in watching television or you get addicted for social media websites or something like that, then definitely your concentration on study is going to come down actually. Now next we have partial correlation. In partial correlation, more than two variables are considered, but only one variable, only two variable influencing each other is considered. The effect of the third variable is kept constant. That means if you have three variables X, Y, and Z, Z may be considered as a constant, whereas X and Y is considered to be varying. In such cases, we call it as a partial correlation. So partial correlation is type of multiple correlation in which one of the variable is kept as a constant. Now, for example, Suppose the yield of the crop may depend upon the amount of rainfall and the fertilizer used here. But we may keep a particular variable as a constant. Say, for example, the area of land, the area of the agricultural land may be kept constant. So by keeping the land constant, we are looking at only two variables. One is the rainfall, the other one is the fertilizer. So such type of correlation is called partial correlation. So other things are, I think it's been already explained. It's very clear about that. Now, what is linear correlation? So correlation is said to be linear when the amount of change in one variable tends to bear a constant ratio to the amount of change in the other. That means if both x and y is increasing in a proportionate manner, we call it as a linear correlation. For example, x is increasing as 1, 2, 3, 4, 5, 6, 7. Y is increasing as 5, 7, 9. You can see that for every one increase in value of x, y is increasing by 2 times. So therefore, y is equal to 3 plus 2x. This is called linear correlation. Non-linear correlation, here the its amount of change in one variable doesn't bear a constant ratio. For example, x 1, 2, 3, 4, 5, y 7, 14, 21, 28, 35. Now here you can see that the y is increasing like so it is in the increasing the ratio of 1 is to 7 actually. Now this is also I think there's a mistake here. This is also a linear correlation. Suppose instead of um, yeah 14 you have 30. So 7, 13, 21, 28. Then the proportionate increase of x and y will not be proper actually. So then we can call it as a non linear correlation. So basically there are different methods of calculating correlation: scatter diagram, Karl Pearson coefficient correlation, then the rank correlation or Spearman's rank correlation. So in the syllabus for third BBA business statistics, only two methods you have to focus. One is Karl Pearson coefficient of correlation and Spearman's rank correlation. So method 2 and 3 alone is required here. So let us go to the Karl Pearson method. So Karl Pearson is also called as the father of the statistics. So he has given this particular method for calculating the correlation. Karl Pearson coefficient correlation basically deals with calculating what is called as the coefficient value called R. So R can have a value between -1 to +1. So the coefficient of correlation R measures the degree of linear relation between the two variables x and y. So in general, see the Karl Pearson coefficient correlation is given by this formula: R is equal to numerator sigma xy divided by square root of sigma x square into sigma y square. So this is the formula for coefficient of correlation. Now sometimes you may have to interpret the value of R. As I told earlier, the R can have a range of value from -1 to +1. If R is equal to +1, then correlation between two variables have to be perfect and positive. If R is equal to -1, then the relation between two variables have to be perfect but negative. If R is equal to 0, then there is no correlation between the variables. So whenever you're calculating, always you have to ensure that the R you are getting maximum is +1, minus is the least is -1. So in between you can get any value at it. So let us look into the calculation of the correlation by using the Karl Pearson method. Now, whenever you're calculating the Karl Pearson method of correlation, there is one more factor we'll be calculating, what is called as the probable error. So probable error of coefficient correlation gives us two limits within which the correlation coefficient the selected series at a random from the same universe is likely to fall. Now later on, the modern statisticians found out there is some sort of error factor. So this is the probability of getting a error factor. So this error factor is calculated through a limit action. Now for that we'll be using one particular formula 0.6745 into 1 minus r square divided by square root of n. Now this is actually called as the probable error. Sometimes they will ask you to calculate coefficient of correlation and also probable error, including the limits of probable error. So in such cases, you have to use this particular formula. Now let us go to the problem. Then I will explain how to calculate the limits. So here you can see the formula for limits. P is equal to R plus or minus PE. That is, this is the positive negative limit you have to calculate here. Now suppose if they ask you to calculate the probable error. So this sort of questions, example number 1 is for 2 marks. So here they are given the correlation value. If R is equal to 0.6, so R is called as coefficient of correlation. N is equal to 64 of a distribution. Find out the probable error. So this sort of question they may ask for 2 marks. So find out the probable error from the coefficient value and the N value. So we know that N is 64, R is equal to 0.6. So if you substitute in this particular formula, you will be getting 0.06. So for this, you will be getting 2 marks. Similarly, given the following, calculate the n. So n you have to calculate. So other values are given. So you have to cross multiply. And if I want to remove the square root, so I have to square it. So then you're going to get the n value as 10.42. That means approximately you can take it as 11 here. So these are the simple problems that you may get on the probable error. Okay, let us go to the main problem of correlation. So example number 4, the following data relate to the age of employees and the number of days they have reported sick in a month. So you have age as well as the sick days. So age is taken as X, the sick days is taken as Y. So these values are given here. Based upon that, you have to calculate Karl Pearson coefficient of correlation. That is R you have to calculate. So there are different methods of calculating R. One is actual mean. One is the deviation taken from the assumed mean you can calculate. So there are different methods. So here the value is calculated by taking the actual mean. So first what you have to do is, so X is given here. So you have to calculate the X bar. So what is X bar? X bar is equal to sigma X divided by N. So sigma X is nothing but sum of the X values. So sum of the X values is coming to 460. So 460 divided by 10, because 10 values are there, you will be getting 46 as the mean. Now similarly, you have to calculate mean for Y also, that is 6 days. So sigma Y is coming to 40. So 10 values are there, divided by 10 is going to give 4. So the mean for X will be 46, mean for Y will be 4 here. Now you have to take the deviation. So small x is equal to capital X minus X bar. So you have to take a deviation from X bar. So that is the mean of X values. So this is how you will be getting the deviation. Then you have to square it. That comes to X square. So then you have to take the sigma X square, that is coming to 1092. Similarly, for Y you have to take a deviation. Small y is equal to capital Y minus Y bar. Then you have to square that small y, comes to Y square. Then you have to take this sigma Y square value. Please remember, in case of actual mean, if you are calculating a particular correlation value, then you have to use this particular formula. What is the formula for calculating the coefficient correlation? In case of actual mean, R is equal to sigma xy divided by square root of sigma x square into sigma y square. Here xy is small xy. So here small x is nothing but capital X minus X bar. Y is equal to Y minus Y bar. So that is how you have to assume and you have to calculate here. So this is how it is calculated here. You can see here. Small x is equal to x minus x bar. Small y is equal to y minus y bar. Small x square, small y square values and small xy values, you have to take it. So if you substitute in this particular formula, you will be getting as plus 0.87. So this is a positive, it has a high degree of positive correlation. That is the inference. Now let us take one more example. Calculate Karl Pearson coefficient correlation from the following data. Marks in economics and banking. So here capital X is given as 170. Now here we have to use the actual mean method. So as I told earlier, actual mean will be this particular formula, sigma small xy divided by square root of sigma small x square into sigma y square. So small x is nothing but x minus x bar. So x bar is sigma x divided by n. We are getting as 34. Then you are getting as 35 as the mean for x and y. You have to take a deviation. Then sigma x square you have to calculate, sigma y square you have to calculate, sigma xy you have to calculate. If you put this into this formula, you'll be getting as 0.429. This is the coefficient of correlation by Karl Pearson method. Similarly, another problem. So we have the marks in accountancy, marks in English. So these marks, what you have to do, first you have to calculate the mean, that is the average of x and average of y, that is x bar and y bar, 49 and 45. Then you have to take a deviation. Then you have to calculate small x square, small y square, their totals, and xy, small xy, and their total. And put this into formula, you will be getting the R value. Now, in this particular problem, they also asked you to calculate probable error. Now, based on this R value, you have to calculate probable error. So, how to calculate probable error? Probable error is equal to 0.6745 into 1 minus R square divided by square root of n. You have already calculated the R as minus 0.666. You substitute that, the probable error you will be getting is 0.1187. So, this is how you calculate the probable error. So probable error need not be calculated every time. If it is asked, you have to calculate the probable error. So this is another different type of problem. From the following table, calculate or find the coefficient of correlation between age and playing habits of the students. So age in years, number of students, regular players are given here. So age in years is given 15, 16, 17, like that it goes on. Number of students is given here. Regular players are given here. So here you have to calculate the correlation. So little bit modification you have to do. The age of the student is represented as X here, and the percentage of regular players is taken as Y. That means how many players are actually playing out of the given students. So that percentage you have to calculate. So age of the number of players are given here, the number of students are given here. Okay. Now actual percentage of the regular players you have to calculate. So how to calculate? We know that so number of regular players is 200, but actual students is 250. So that percentage comes to 80, 75, 60, 40, 30, and 15. So this percentage becomes the Y, and this age group of the students 15, 16, 17 becomes X. So that is what you're seeing here. So 15, 16, 17 age group percentage is Y. So once again you have to calculate the actual mean deviation from the actual mean, then x square, sigma y square, sigma xy. These values you have to substitute and calculate here. You are getting minus 0.738. It means highly negative correlation. So whenever you get negative, it means negative correlation. Positive means positive correlation. Now let us go to the next method of calculating correlation, that is called as Spearman's rank correlation. Now the question is why we have to use the Spearman rank correlation when Karl Pearson method is already given. In certain cases, you cannot calculate the correlations. For example, if I want to measure the correlation in certain qualitative factors like leadership, ability, judgment of a contestants in a beauty contest, like that, or the motivation, perseverance, these sort of qualitative factors, then you cannot use the uh, Karl Pearson method. In such case, you have to go to the Spearman's rank correlation. So Spearman's rank correlation is given by this particular formula. So what is the formula for Spearman rank correlation? This is the formula. R. So sometimes in some certain textbook it is represented as like this. This is called rho. RHO. This is called rho. It's a Greek alphabet. In certain textbook, it is written as a rho. It's like this. So inverted P or P. Now this is called rho. So in certain textbook, it's given Rn. So rho or Rn is equal to 1 minus 6 sigma d square divided by n cube minus n, or 1 minus 6 sigma d square divided by n into n square minus 1. The actual formula is like this. So when you simplify, it becomes n cube minus n. So R represents the rank correlation. D represents the difference of ranks between the paired items in the two series. And n is the total number of observations. So what are the characteristic feature of the Karl Pearson method? Same thing applies for Spearman's rank correlation also. Suppose in case if the ranks are repeated, now in case if ranks are repeated, then you have to use this particular formula. Please remember this formula to be used and ranks are repeated. So here we'll be taking one variable called m. So m basically tells how many times a particular values are repeated. Suppose if there is two repetitions are there, then you will be having m1. Then say for example, if there are three repetitions, three set of repetitions are there, then you will be having m1, m2, and m3. So m basically tells about like how many sets of repetitions are there. The three sets are there, then you have m1, m2, m3. Within the set, suppose if it is repeated two times, then m1 will be having 2. So similarly, the values of m2, m3 also is going to vary. So I'm going to explain this later with a set of examples, then you will understand. So let us go to the simple correlation, Spearman's rank correlation problem. Then later on I'll explain the similar ranks. So the main merits of Spearman's rank correlation is very simple, easy to understand, easy to apply, and understand the concept. The method is useful whenever ranks are given but not the values. So when ranks are given, when you have a qualitative factors, so quantitative factors can be converted to qualitative factors, or qualitative factors can be converted into quantitative factors by using ranks. So this method is used where initial data is form of ranks. Now here, the problem is given here like this. From the following data, calculate coefficient of correlation between x and y by using the rank correlation method. Rank correlation method. Now here, if they are going to ask you rank correlation method, then you have to calculate rank correlation. So since they asked here to calculate the coefficient of rank correlation, so you have to use the Spearman's rank correlation method. The values of x, what you're saving, 36, 56, 20, 65, are actual numbers. But in rank correlation, you cannot use numbers, you have to use the ranks. So that means what? You have to rearrange these numbers in descending order. Then you have to calculate the ranks. So how to calculate the ranks? So you have to put this in a descending order separately. Now, for example, if I put this in descending order, what number comes first? 65 comes first. Then you have 60 that comes to second. Then 56 comes the third rank. The fourth rank goes to the 50. The fifth rank comes to 44. The sixth rank comes to 42. The seventh rank comes to the 36. Eighth rank comes to 33. Then ninth rank comes to the 20. So like this, you have to put the ranks. As you know that ranking is then based upon the highest values. So highest value should get the first rank. So next highest value should get the second rank. Next to next should get the third rank. So that is the criteria we are following here. I hope that is how you got this R1. So R1 is calculated based on this ranking technique. Similarly, Y ranks are calculated in the same way. So initially you have to take these numbers in separately in a descending order, then calculate these ranks, and appropriately you can put this rank. Similarly here, if you take Y series, so the first rank goes to 80. So this will be first rank. So second rank will be 75. So the third rank goes to 70. So like this, you can put the ranks. So correspondingly, ranks are taken here. So R1 is the corresponding ranks to the X values, and R2 is the corresponding ranks to the Y values. Then you have to calculate D. So D is equal to R1 minus R2. So that totally you have to calculate that sigma D is coming to 0. Then D square you have to calculate, that is square, you have to square these values. So 1, then you have 6 square 36, 36, 9 square is 81. So like that total comes to 318. Then you have to substitute this value in the Spearman's formula. So what is the Spearman's formula? R or RK or rho is equal to 1 minus 6 sigma d square divided by n cube minus n. So n here is 10. So 10 cube minus 10, 6 into 318. Substitute and subtract that. You'll be getting minus 0.92. So that means it can be abbreviated to 0.93. So this is the coefficient value. So let us take one more problem. Similarly, x and y is given here. You have to rearrange separately. You have to take ranks. So 154 is getting first rank. This is second rank, third rank, fourth rank, fifth rank. Like that you are getting. So first convert ranks. X values into ranks. That is R1 ranks, and Y values into R2 ranks. Calculate D is equal to R1 minus R2. Then D square. Put that into formula. We'll be getting the rank here. Rank correlation. So what is rank correlation here? 0.9524. Now, this is a problem where the values are converted into ranks. So sometimes they may give a problem like this. So example number 13, 10 competitors in a beauty contest are ranked by 2 judges in the following order. Judge 1 and 2. Judge 1 is 1, 5, 4, 8, 9, 6, 10, 7, 3, 2. And judge 2 is 4, 8, 7, 6, 5, 9, 10, 3, 2, 1. So directly you have to take this as ranks. There is no need to do the conversion. If values are given, then it should be converted into rank. Your ranks are directly given, so you can take it as R1, R2, find out the difference. So then D1 square you can calculate. So that comes to 57. So put this into this formula, you'll be getting 0.6546. So what we are doing is directly we're taking the ranks here, because the problem is given here is ranks only. The values are not given. In the previous problem, the numbers were given which were converted into ranks, but here directly ranks are given. So directly take this as rank R1 and R2. Then calculate D is equal to R1 minus R2, then D square, then put that D square value. So 1 minus 6 sigma D square divided by n into n square minus 1, that comes to 0.6546. So this is how we calculate. Now what to do in case when you have a common rank? So common rank is something where ranks gets repeated. Now let us take an example. Now here, if you take these x values, if you put ranks here, 60 will be getting 1. Then if you look at the next highest values is 35, 35, 35, 35. And one more 35. So 4 35s are there. That is second rank is 35, third rank is 35, fourth rank is 35, fifth rank is also 35. So 2, 3, 4, 5. These ranks should be averaged. Since 35 is repeated 4 times, where it is repeated 1, 2, 3, and 4, you have to take the average of these ranks. So in common ranks, ranks are repeated. You have to take like this normal ranks divided by number of ranks pooled together or group put together. Here 4 ranks are group put together. So therefore the average rank will be 3.5. That means 35 will be 3.5. This 35 will be 3.5, 3.5, 3.5. So like that it will be there. So the next one will be like, so second, third, fourth, fifth. The next one has to go to 6th rank. So 20th will be the 6th rank. 15 will be 7th rank. So then 7th one will be the 8th rank. Then you have a 9th rank. So like that it is going to be calculated. So when number gets repeated, you have to take the average of next repeated numbers. Then that ranks are taken here. Now for that you have to use this particular thing in the regular formula. What is that one? Sigma d square plus of 1 by 12 into m cube minus m. So m basically tells the items in the series and the ranks are common. So when you have a common rank, then you have to use this m factor. Now let us take this an example. I will explain this with an example. Now here in this example 6.3.1, the competitors in a beauty contest were ranked by three judges as follows: Judge A, B, and C. So you have a rank given here. Which pair of judges have the nearest approach to the common taste in beauty? So when they ask pairing, you have to find out the permutation of the pairings. So what are the groups you can do? A with B you can do, B with C you can do, then C with A you can do it. So that is how these ranks are taken here. Now here rank A, B, C is taken here directly because these are all ranks. So A, B, C direct ranks are taken here. Then you have to find out the D1. D1 is rank A minus rank B. That D square is D1 square is calculated. Then you have D2. D2 is rank B minus rank C. Then D2 square is calculated. Then you have D3 rank A minus rank C. That is D3 is calculated. So differences are calculated here. Then D1 square is 41. D2 square is 193. D3 square is 218. So here when you look at this problem, so directly you cannot calculate here because some ranks are repeated. Now, what are those ranks you can see here? When we compare judge A and judge B, we find out that in series A, three ranks, 7, 8, and ninth ranks are tied up. Okay, 7, 8, and ninth ranks are tied up. So that is, if I take this particular A, then you can see here the ranks are like this. Then 1, 2, 3, 4, 5, 6, 7, 8, 9 is repeated here. So 8, 8, 8 is repeated here. Now you have a repetition here. So in series A, 7, 8 ranks are tied up. And similarly in series B, 2 rank, 5th and 6th rank, and 8th and 9th ranks are tied up. So for example, if you take a series B, like you have 5.5, 5.5, 8.5, 8.5. For each repetition, you should have one M variable. Now, since in A, three ranks are repeated, 7, 8, and rank, you have M1. So you'll be getting M1 here. So this is M1. So M1 is equal to 3. Then here you have 5th and 6th rank, therefore you have M2. So M2 is equal to 2 here. Then one more is M is here, that is M3. 8th and 9th rank is repeated here. So therefore it is 3. I'm sorry, not 3, it is 2. Now here we have the formula. So when you're using this particular formula, so you have to be very careful. So you have to ensure that this particular M factor is taken into the formula. So how to take this one? So the formula is like 1 minus 6. Outside the bracket, always remember in common ranks 6 you have to take outside. Outside 6 sigma d square plus 1 by 12. This is m1. M1 is 3. So m cube minus 3 plus 1 by 12. M2 is 2. 2 cube minus 2 plus 1 by 12. M3 is also 2. So 2 cube minus 2. Whole thing divided by n cube minus n. So when you substitute these values, you'll be getting 0.733. Similarly, if you take B series and C series, if you take problem in B and C series, already B have 5, 5.5, 8.5 repetitions are there. In C also we have a repetition. What is that repetition? So what is the repetition we are getting in B and C? So in B, 2 ranks getting repeated, 5th and 6th rank, and 8th and 9th rank is getting tied up. In C, 3 ranks, 1st, 2nd, and 3rd, 4th, 5th, and 6th, and 8th, 9th, 10th ranks are tied up. So you'll be having M1, then you have M2, then you have M3, M4, and M5. So M1 is 2 times, M2 is 2 times, that is what you're seeing here. Then M3 is 3 times, M4 is 3 times, then M5 is 3 times. So that is how you will be getting M1, M2, M3, M4, and M5. So put all these values, so you'll be getting minus 0.21. Then similarly A and C, if I take A and C, in A already we know 3 ranks got repeated. In C, the first 3 ranks are getting repeated. Then 4, 5, 6 getting repeated. Then you have 8, 9, 10th rank repeated. So then how many variables you will be having? You will be having one variable M1 for the first one. I'm going to show this one. So this is for M1. So this is M1. So M1 is 3 year. Then M2. This is M2. This is M2. This is once again 3. Then M3 once again 3. Then M4 once again 3. So you'll be having M1, M2, M3, M4. Now if you put this into a particular formula, this rank correlation formula, as I told earlier, you have to keep the 6 outside. Keep the 6 outside and calculate sigma t square. M1 cube is 3 cube minus 3, 3 cube minus 3, 3 cube minus 3, 3 cube minus 3. Entire thing should be divided by 12, 12, 12, 12. Then whole thing divided by n2 minus n, you'll be getting minus 0.6397. This is how you calculate it. So this is a problem where the values are converted into rank from the marks obtained by 8 students in accountancy and strategies. Compute the coefficient rank correlation between the two subjects, accountancy and statistics. Now if I take ranks, so how to take ranks? So ranks should be taken like this actually. Now as I know that, so highest thing should get the ranks. Just a minute. So this comes to the first rank. So 80 is first rank. Then 60 is next highest is 60, third rank. I mean second rank. 40 is third rank. 28 is the fourth rank. Okay. Now here we have two 20s are there, 20 and 20. So this should be fifth and sixth rank. So therefore it will be 5 plus 6 repeated 2 times. Okay, so it will be 5.5. It will be 5.5. So 5.5, 5.5. Fifth, sixth, then you have seventh rank. Seventh rank is 15. The eighth rank is 12. So like that it goes on. Now in y you don't have any difference here, so it's unique number, you can take as it is. The ranks converted in x is like this: 2 7 5.4 by 4 8 3 1 5.5. So y as usual we are calculating, d we calculating difference d square, then d square we are calculating here. So 81.50. So since we have two repetitions, so for one repetition, because we have a tie up in ranks here. So one, yeah, in case of y, you can see that 60 is 1. The second rank goes to 50. The third rank goes to 40. Then after that, you have a repetition. So what is that repetition you are getting here? 30, 30, 30. Three times it's getting repeated. Yeah, we have a repetition in y also here. 30, 30, 30. So 3 times it's getting repeated. So 3, 4, 5. So that repetition is coming here. So that average comes to 5 here. So 5, 5, 5. Then you have 7. Then you have a 8 here. So in X series, 5th and 6th rank is repeated. In Y series, 4th, 5th and 6th rank is repeated here. So therefore, you have M1. M1 is 2 here. So for this, you have to take M1 is equal to 2. So this is for X series. Then M2, you have 3 repetition. So what are the 3 repetition we are finding here? So we are getting this 5, 5, 5. So, okay. So 1, 5, 2, 5. Then you have 3, 5. So therefore you have a 3 repetition. So 2 set of repetitions are there. So first set is for X series. The second set is for Y series. So this is 2, this is 3. So therefore M1 is equal to 2, M2 is equal to 3. Now this you have to put into the formula. So when I put this into formula, So you'll be getting as 0. So 0 means there is no correlation between X and Y. There is no correlation between the marks taken by students in accountancy and statistics. So this is how you calculate the rank correlation when ranks are repeated. So kindly don't forget to remember this formula: sigma t square plus 1 by 12 m1 cube minus m plus 1 by 12 m2, I mean m cube, m2 cube minus m2. So this formula you have to use it here. So I'm going to highlight that particular formula once again here. Yeah. So this is the formula that you have to remember. This is the extra thing you have to use in the formula, and this is how common ranks are calculated by taking their average ranks or values. So I hope that you understood the correlation chapter. So in these two important methods you have to remember. One is the Karl Pearson coefficient of correlation and Spearman's rank correlation, and also the calculation of probable error. So these are the three important things that can that you can expect in the question paper in the chapter called correlation. So thank you very much.